you so much for checking out the 8th episode of the Weaviate Podcast. Today I'm joined with Karen Beckers, a data scientist at Squadra Machine Learning Company. Karen, thank you so much for coming on the podcast. Can you tell us about how you're using the Weaviate vector search engine?
Yeah, thank you for having me. I'm really excited. As you said, I'm a data scientist at Squadra Machine Learning Company, and we're a company that provides customers with AI and data science solutions. On the one hand, we have our own products. Then we focus on suppliers, wholesalers, and retail. And with those products, we provide solutions for smart product data management, supply chain optimization, and as we like to call it, AI commerce instead of e-commerce. But on the other hand, we do projects. And in these projects, we provide data science solutions for any specific task that a customer might have. And this is actually where Weaviate comes in, because for one of our customers, an e-commerce customer, we're building a search engine. And we're doing this a little bit different than the more traditional methods of search. So we're actually building the search engine based on the image relevance. So we started out with a proof of concept of only 1,000 products, just to see if it was actually possible. Can we get relevant results, results that are relevant to the query based on the images? And at that point, we were just brute forcing it. So we calculated the vectors, we just brute forcing the vector similarity. And of course, that doesn't scale if you're going to a larger data set. So we had to transform to a different platform. And so that's when we stumbled upon Weaviate. And since then, it's been so much easier. The whole process has been so much easier. And yeah, it's really great to use Weaviate.
Yeah, I think that idea of using an image to search for products is so interesting. And I've seen demos of, say, like the fashion MNIST data set to give kind of like a illustration of what this looks like, where you say take a bag and then hit the data set of bags to find the most similar looking bag. What kind of data sets are you using to kind of bring that to the real world? Is, say, like maybe Pinterest have an API, or like how do you get the data set of real world, these e-commerce kind of pictures?
So the data that our customer uses, they scrape the data from brands that they are selling, and we're using a zero-shot model that is actually able to map textual text and images to the same vector space. And for search, it actually works well, and we're also using it for classification. But for classification, you can do some, like after the vectorization, you can do a linear probe to, match the vector a bit better to the categories.
That sounds so interesting, like that pipeline of so you could have an image search, a text to image search, and then you can also append a classifier with the high level discrete variables of bag, shoe, or maybe brands like Nike, Adidas, or that kind of thing. So what kind of so with the text to image search and the image to image search, what kind of are the two different things that go into each of those things?
So for the thing, if you use text to image, then you can also expand that to text and then combine those. And the difference with image to image is that you only have that image. And so we're using the model that I just mentioned that maps text to the same vector space as images, but we're also using only text models. So if you do text to image, then you can use both. But if you do image to image, then you only have that image model. So you only can make use of the information that is stored in the image, which is also a challenge, but that's interesting, of course.
Yeah, it's so interesting. You can also like label it with the symbolic metadata that describes the images as well, to have that kind of maybe sanity checking for the image search. I'm curious about how you evaluate the, do you annotate, say, like the top K, and you have annotations of the best nearest neighbor for images, or how do you kind of evaluate an image search system at scale?
Yeah, that's difficult because we don't have a golden standard of a set of queries that we know that these products have to come up in the top 10 results. We don't have that, so that's difficult. But we are now using a tool called Cupid, where you can the tool lists your top 10 results, and you can annotate them yourself with either binary measurements or on a scale. And then as you update your algorithm and different results come up, then that automatically updates as well. So you at least have a quantitative idea of how good the results are.
Yeah, that's so interesting. So Cupid is a labeling software. Is that correct? I'm really curious about these kinds of things. And can you tell me a little bit more about what Cupid does?
Yeah, I'm actually just getting into Cupid myself. We started on that, I think, 2 weeks ago. So it's very new. But it's not in that sense a labeling software. Um, it's maybe more a relevancy tool for any search engine. So it's actually it's pre-built for Solr or Elasticsearch, but we just rewrote our Weaviate output so that it looks like Elastic output, so that the tool can actually interpret that. But I think just for any search engine, you need a tool to score your results, to say, okay, how well is my system actually doing? And Cupid is just one of those tools that can help you with that.
Yeah, thanks so much for that. I love following along with these labeling softwares, and I see like the big name things like say Scale AI and Snorkel AI, the things that I think most people are aware of. But also been looking into things like rubrics and learning more about these tools. I think it's such an interesting part of this. So the next question that I love to ask on the Weaviate podcast, and I think especially for image to image and text to image search, is such an interesting different angle. Is usually we're talking about text to text search, where we have all these say sentence transformers, and the Hugging Face Model Hub I'd say is mostly geared towards natural language processing. But so how well does say using a ResNet 50 trained on ImageNet just right off the shelf, taking those pre-trained embeddings and then using that to image to do image to image search in the transferring domain from the 1,000 or so classes in ImageNet into eCommerce? How's that off the shelf transition from pre-trained model into application?
That's a good question. Yeah, so the model that we're using, it's not the pre-trained ResNet, or it is one of the versions actually ResNet based. But this one it's just trained on the, basically what they say is like whole Wikipedia, whole internet, with the images and the labels, the metadata labels that are with the images. So that gives you a whole, like a very broad scale of what the model actually knows. So that's really great. But for a really funny example, actually, what we saw that the model was trained up until I think maybe 2019, so pre-COVID, and so it doesn't recognize face masks. So that's actually very funny. But of course, now face masks you can't, like, you see them everywhere. There's such a normal view on the street, and the model just doesn't know those. So that's difficult.
Wow, yeah, that's such an interesting part of the updating information, and that's one of my favorite things about decomposing deep learning tasks into retrieve and then read, because when you separate it into a separate retrieval task, you can easily update the information compared to having one running supervised learning model, and you just try to like update the information by doing further gradient updates with some new data set. But I love how you could just drop in a new retrieval data set with the face mask to have that adaptation. And yeah, I think that's such an interesting part. So is this the OpenAI clip model that you're using?
Yeah, exactly.
Yeah, I really like this paper. It's they use this weight space ensembling technique where they go from the zero shot generalization of clip trained on all of the internet, and then they fine tune it on particular data sets. And these are like academic benchmarks. It's not like quite like e-commerce product matching, but they show that if you do that weight space ensembling along the path from the pre-trained clip checkpoint into the fine-tuned representation, then you get like the both the zero shot flexibility as well as that like in distribution fine tune thing. So do you have like particular ways of evaluating that idea of the out of like the how you would say how flexible it is, how robust it is compared to the evaluation on the fine tuned data set?
No, that's actually very difficult right now because we haven't fine-tuned clip ourselves, mainly because we don't have a large enough data set that's actually labeled. That was
Hmm.
also the challenge that brought this customer to us. Their data isn't labeled, um, and we had a blog on Medium actually about image classification. So that's how they came to us. Um, so that was already a challenge for us. Okay, we can do image classification, but it's difficult if we don't have any labeled data. So that's why we turned to Clip, and then that actually turned out to work really well. Um, and we're also we're constantly thinking about how can we improve, how can we fine tune the model. But if we don't have any labeled data, then that's really difficult. So
Yeah, I see the like the idea of using transfer learning to label data for some other domain, or say yeah, like this idea of maybe you might call it programmatic labeling, where you have the pre-trained model that you're now using to label data. It kind of reminds me of say like semi-supervised learning as well,
oh
where
yeah.
you know propagate it and go label the unlabeled data. And yeah, this is one of the things like coming back to these say like open source labeling software tools. The Rubrics framework has a great interface for this idea that we're describing of you use the clip model to label your unlabeled data set. And I think that's such an interesting topic with like bootstrapping unlabeled data sets and then maybe pushing those to say like the Hugging Face data sets or something where people can collectively use them and build on them.
Mhm.
What kind of vision and language data sets like inspire you to work on them? Maybe like visual question answering or visual common sense reasoning. I see maybe like a lot of vision based robotics where the labeling is like follow instructions through some kind of thing, something like that. What kind of vision and language data sets interest you the most?
Um, I have to say, like, except for we're not doing a lot of vision vision projects right now, so we're mainly using Clip for that. We do use a lot of language models.
Mm-hmm.
Um, there was this project where we trained the Google T5 model. We use it to train a paraphraser. Um, and we've been using BERT, census BERT. Uh, um, so I think maybe those are maybe the more standard models, but I think right now the model that has the most promise, that has been proving to be the most promising for a lot of projects that we're working on, is probably Sentence Bird.
Yeah, sentence BERT is so cool. I love these like the Siamese architecture of the decomposition
Mhm.
of BERT into just something that's intentionally producing embedding. So the yeah, the text description, so writing some kind of description that describes the product, is that kind of it's an interesting thing to me is whether you want to take like an image of the shoe that you've seen on maybe you're watching a TikTok video and you see a shoe that you like and you want to just take a picture of it and use that to index like Amazon or or whatever to get the
Mhm.
product. But compared to writing a language description of the thing you're looking for, do you think the language description is maybe a more say like robust path for search than image based search?
Mm, I'm not sure actually, because as they always say, like a picture says more than 1,000 words. I think that probably, uh, I think that probably is true for this as well, right?
Mhm.
You will always describe the image or the product from your own imagination, and if that doesn't really match, um, or it's
Mm.
just differently nuanced from um, how it's represented in vector space, then that could be problematic, and then maybe an actual image is more robust.
And you could probably do both as well, right? Like have the you send the image and then maybe it's like just inspiration and you're trying to like
Mhm.
I like this sneaker, but maybe something that's more so I don't know what kind of textual description would expand on this particular sneaker, but the combination of language and text to search for something, how would that kind of thing work?
Yeah, that's really interesting. I thought I read an article a while back that's saying that Google is actually working on that right now. That you can upload an image and use a textual description. I'm really interested to see how that would work. Um, I don't have any experience with that. I imagine, yeah, maybe you can combine the vectors in some way. Say if you would map the vectors to the same vector space, and maybe you can calculate an average of the two vectors combined that has that both information, the information of both entities combined. I'm
Hmm.
very interested to see how that would work.
Yeah, I love that idea, and like also maybe combining it with like the symbolic annotation, which I want to ask about next. But yeah, I love the Google, say the landmark detection competition they host on Kaggle. I think they host that every year, where you have an image of say Eiffel Tower, and then you index their database to find the other image of the Eiffel Tower. And I think this is one of the most long running nearest neighbor open source competitions on Kaggle, and yeah, it's such an interesting idea of adding on the text to further enhance that like image, text image kind of search thing. So I want to talk about symbolic filters, and like symbolic search seems to be basically solved where if you have the symbolic annotation on the products in the query, you can just exactly match them and say they're exactly
Mhm.
matched. So could you extract the symbolic filters from the text description so people don't have to be like entering their schema and have this kind of fixed schema, whereas they can just write natural language descriptions and then from there you can create a symbolic kind of tagging from it?
Yeah, we do that in some sense, where we have one of the products actually that we have at the machine learning company, um, is a feature extraction tool where you can upload a product description, and then you also upload your data model, so you know the whole taxonomy, you know what features there are and what the possible values are, and then the algorithm extracts those features from the text. Um, so we're also doing that for this customer as well, and we're trying to enhance it with image feature extraction.
Mhm.
So where we accept, for example, color. You have a list of colors, and then you can say, okay, what color matches this product best.
That's super cool. That because that kind of adds like the symbolic filtering of say regular expression matching in text to images, where you can find the color exactly by using the by having
Mhm.
just the pixel that appears in the thing. Can you tell me a little more about this mapping from like unstructured data, like images or just a language description you describe your product with, into structured data where you have that data schema, you have that kind of predefined model of what your data looks like. How does that mapping from unstructured to structured data look?
So on text base, we mainly use regular expressions, but of course, you can also provide a list of synonyms, and then you have a really elaborate system that can extract those elements from the text. But then, of course, there's also the possibility when the product is actually red shoes, but then the description says you can also pair this really well with your blue jeans. So then extracts red and blue. Um, and for that, we actually again use some vector representation to determine which color is actually best fitted to the product. So use the context of the whole text to determine which value is actually true.
Yeah, I love that dimension of adding symbolic filters even within the same data domain. So for like searching for images, if you search not just for say another shoe, but like then a whole outfit to be returned, and you add the symbolic filter onto what's being returned. And this is kind of like one of the more technical details in Weaviate that I really like talking about is the like the pre-filtering step on HNSW, where they actually cook these symbolic filters into this massive vector index that can do something like search for through 100 million vectors of pictures of shoes and e-commerce
Mhm.
products. And I think it's so interesting. So So on that also though, coming back to symbolic and structured data, and we talked about fusing embedding spaces of image representations and language representations. Could we form, say, using techniques like contrastive learning or maybe mass autoencoders, representations of the structured data as well, and then have that further embedding space alignment between images, language, and then the structured data as well through some deep learning technique to encode the structured data?
That's a very interesting idea. Um, I think if we can, that would of course be very helpful because with the symbolic data, you're almost always restricted to keywords or a list of synonyms, and that's never complete. So if we can actually have some kind of embedding space that incorporates everything, that would be awesome, of course.
Yeah. Yeah, I think like the multimodal learning, the ability to combine all these different kinds of data, I think that's what's driving, like what's on the frontier of what will drive so much progress in this technology kind of. So with these advances in deep learning for search and e-commerce, can you maybe tell me some things that, not to name any particular e-commerce platforms, but some of the things that are missing that really need to be added or on the, like the cutting edge of like new features in e-commerce?
um, with deep learning, well, actually, I think um, maybe what we're doing, what we're trying to do right now, retrieving products based on the images. Um, I think that would help a lot if that. Of course, it's still an ongoing process, and it's very difficult to tune it well and get the proper results because sometimes you do need the textual fields to get the actual good results. But if we can already establish a baseline based on the images, then I think a lot of e-commerce platforms could benefit from that. That if their suppliers provide the data, then of course there's always noise in that,
Hmm.
and maybe some suppliers they don't provide the data in the correct format, and so if we can enhance that with the images or some automated in an automated fashion, then that would really be a helpful thing.
Yeah, I love the idea of, say, when you see some funny thing at Home Goods and you take a picture of it and then it indexes like Etsy, eBay, Amazon, and you have this whole like that idea of going from an image into the whole catalog of all the things on the internet, I think is like such an interesting topic with things that might be on the frontier and like new ideas in e-commerce. So I wanted to ask you about what you think about kind of open source generally and the idea of, say, providing demonstrations of what your technology can do on, say, Hugging Face spaces, and how there are these easier interfaces to build and share user interfaces with tools like, say, Gradio or Streamlit, as well as kind of the general topic around, say, open sourcing data sets and publishing papers.
Um, I'm actually not familiar with Gradio Streamlit, but in general, open source data sets and open source models and the whole open source community, I think it's actually for us it's great because a lot of times we get customers that like they're not uh, their company isn't that large, so they don't have that like great amounts of data, and the data is often not structured well, or it's really noisy. So then it's always difficult. You know that there is an AI solution that will work for them, but if you don't have the data to train that model yourself, then that's very difficult. So using those open source models and being able to base like have a foundation based on those, and then being able to fine tune it with the smaller set of data that you do have, that is really helpful.
Yeah, that like collection of pre-trained models and like coming back to the pre-trained Siamese BERT, sentence BERT. I'm not sure what the S stands for in SBERT. I think it might be sentence BERT, but
Yeah, I think
or
so.
but yeah, like the boom in the pre-trained architectures, it enables such a like starting point, and also like kind of in taking down the cost of training these models because you have the pre-trained checkpoint, so you don't need, even with your smaller data set, generally you don't need to tune it for as long. Do you see the cost as being one of the other like big selling points of these pre-trained models?
Yeah, exactly. We if you would, for example, a GPT-2 or even GPT-3, that's not even realistic to train that yourself with the data and the cost we can have. So yeah, if we don't have to do that ourselves, and that's really helpful. That's great. We can't use that. We can't mimic that ourselves as a smaller company, not one of the larger tech companies in the US, of course.
Yeah, the cost of it is such an interesting part of deep learning because it's yeah to push the cutting edge of it, you need to really have expensive computers and
Hmm.
distributed computers and all the pretty interesting stuff. Have any recent trends in kind of efficiency gains in deep learning been interesting to you?
Um, yeah, there comes one model to mind. I actually forgot its name. Um, yeah, let me think about it. I thought it was really interesting because, of course, with all the bigger models that are out there right now, there's a lot more computational cost, a lot of more, in that sense, electricity use, and all the data centers that are constantly running. And um, yeah, we're trying to be a little bit more environmentally friendly, but data science isn't really. So I read about this model that uses a lot less capacity. That it actually, um, I thought it was multitask, some multitask model, but it would only activate those neurons that it would actually use, and that way use a lot less computational power. I forgot the name about it, but I thought that was very interesting. If we could, um, from a data science perspective, be a little bit more environmentally friendly as well.
Yeah, I think you're talking about the lottery ticket hypothesis and the masks that they put on the network, and it shows that you only need, say, the sparse subnetwork to achieve the same performance as the full dense network. A- And yeah, so
Yeah.
that I think as cool as that sparse masking idea is, I think they still have some like hardware optimizations before you can really completely realize the efficiency gains of applying the masking onto the dense architecture. Because I think right now you're still doing the same computation, you just add the mask to it.
Oh, okay.
So, so I think there's still some interesting things to be developed in that kind of idea. So, kind of more broadly with like data science and then like Weaviate vector search. And I think it's really interesting, maybe this transition in database technology from SQL relational databases into NoSQL, the flexibility of JSON kind of data, the way that it lets you just adaptively update your schema, and now into Weaviate, where we have the flexibility of NoSQL, but plus this deep learning functionality. What do you think about this kind of trend in this tooling for data scientists?
Yeah, I think it's really helpful, especially since we're generally in data science, we're moving a lot more towards using vectors than any other type of data. Um, so having the infrastructure to actually use that and make, because the I think the previous generation of databases, they're really well established, and they're great to use. So going into that new area of vectors is maybe a bit more tricky in the database sense. So using a tool like Weaviate, where you can actually have a solid base for your data, then that's a really great move forward.
Yeah, I think there's a lot of interesting topics with how data scientists will use vector search functionality, and particularly as we've been talking about, the idea of using unstructured data more so, where you just have images or just free form language descriptions of whatever data you're trying to describe, maybe, and then you could go into all sorts of things like audio, video, biological data, graph structured road networks, all these like unstructured kind of data sources that you can use now for standard kind of data science. Do you think the downstream functionality, as we say, describe like nearest neighbor search as retrieve, and then read being you take the retrieval part and then use that as input to some kind of supervised learning model? Do you think supervised learning models will become a more common tool for data scientists? I know we maybe do things like regression analysis and look at the coefficients of regressions and do the correlations. Do you think maybe things like, say, retrieving from your data and then using a text to image model to generate some kind of, say, visualization of your data, or any kind of these creative supervised learning applications, do you think that will become more popular with, say, just like the average data scientist who isn't necessarily like a machine learning research scientist?
Could you maybe rephrase that? I'm not sure I understood it.
Yeah, like the idea of labeling pairs of data, for like labeling XY pairs and trying to
Mhm.
bootstrap some kind of task. Do you think that's something that could become more common with like a typical day in the life of a data scientist? Or in comparison to maybe, say, using mostly, say, like descriptive statistics, looking for like statistics in the distributions of data and the kind of, say, traditional sort of producing charts and that kind of objective of data science?
Oh, in that sense, yeah, I do think that will become more. That we will see that a lot more. Because also think that the models that are out there and the tooling that is out there to use the models is, um, how do you say it? It's more accessible than it was
Mhm.
before. So not only for actual data scientists, but also for people that are not really data scientists, but they're more accessible to use. I actually had an idea once that maybe in the future there will be like a plugin in Excel where you load your data and you push a button in Excel and say, okay, then now train a gradient descent, training a simple regression model, or even an ensemble method. That and then maybe not even people who know about the data science can use those methods.
Oh, I love that idea. Even people who don't even know about data science, like you could just have a natural language, very fuzzy description of what you're trying to do with your data, and it could interpret that and map it into a function.
Hmm.
I've seen Hugging Face added to Google Sheets, and yeah, that kind of integration I think is so interesting, of adding deep learning functionality into, say, just like Excel spreadsheets, but then also, as we
Hmm.
talked about, integrating the unstructured data as well, which I think is such an interesting part of the Weaviate, because with Weaviate you can still have your structured CSVs if you want to look through that and have that kind of JSON data, but then you can also add images and, and language
Hmm.
and things that are more uncommon to this. So with your use of Weaviate, how has that been? Do you have any things that, like, maybe you wish were added to Weaviate?
Well, there were actually already a couple of things that when we started out with Weaviate, I think it was the end of November. Um, some functionalities that we really needed weren't there yet. So, for example, the OpenAI clip model um, that we were using, they didn't have it out of the box in Weaviate yet. So of course, we could import our own vectors and then use a near vector search with that. But then the downside is that for every query, we would have to vectorize the query ourselves. So send an API request to our API, send it back, and all the latency issues that come with that. So that they already that the clip model is actually integrated in Weaviate right now. So that's already great. That's really helpful. Um, but also, I've heard that they're not currently working on the BM25 implementation. So we're really looking forward to that because, as you said, we can use the symbolic data to filter, um, but then the integration of doing actual keyword search, retrieving results based on keyword search, and then combining that with the image results is currently very difficult because there's no score coming from the keyword search, and there is a score from the image search. But then how you have to combine it in some way. How are you doing that if you don't have scores for both? So we're really looking forward to that implementation. But I've heard they're working on it right now, so excited.
Yeah, that's so interesting. And kind of the first thing you said, the modularity of the different vectorizers or the different embedding models, how you have the OpenAI embedding model in embedding models like Clip, or say the latest CPC code, CPC text, and how you can put the model into Weaviate, so you don't need to have two separate APIs. And then I love this idea of the combination of different retrieval models in the same API. So you can have the BM25 and you can have your dense Esper representation all in that same API. And then you start getting into this really interesting topic of how do we interpret this kind of fuzzy distance and combine the outputs of TF-IDF, BM25, these lexical sparse retrievals with dense Esper? How are we supposed to fuse the outputs of them? Do you have any further ideas on this? Maybe say like coming back to the labeling software, maybe we could use labeling software to start annotating the different scores that come out of our model, and then have like another neural layer on top of that interprets the outputs from say 5 different retrievals, where it could be TF-IDF, BM25, and then say 3 different variations of training your Esper model, because the ways that you fine tune it right could lead to different behavior. Do you have any ideas on like how we can combine those outputs?
Yeah, that's actually very difficult, and we've been stuck on that for quite a while now. But it's very interesting what you're saying. We also had that idea that we have all these different components. So we have the image results, but we're also doing text similarity on the product names, and we can do text similarity on any other field that we have, but then also do the keyword search. And then all those different components, how are we going to combine those? And we actually had an idea of training maybe just a very simple random forest and use those weights. Actually, the feature importances of that model to use as weights for all the different components. But right now we don't have a fixed solution yet. So if you have any, then ideas are always welcome, because it's a very difficult topic, and it's still ongoing, and it will probably be ongoing for a while. I don't think it will be solved very soon.
Yeah, I've discussed this with some of the Weaviate team, and we love this, maybe calling this human-computer interaction, this idea of how we interpret these fuzzy distances from neural searches compared to, as Bob describes, the binary output of when you search for something in a traditional search engine, it either contains it or it doesn't, compared to this, where it's like, this is 80% similar to what you said, and you're like, okay, so what do I make of this? And I love what you said with the random forest layer. I think maybe in my studying of deep learning, I'd become like overfit to this idea of putting a neural network onto everything. But when you just have these, 5 different outputs, you could probably just use a simpler, like just a random forest or a,
I always really like not using a neural network immediately, because the whole field of AI, where we're like, especially the past couple of years, everyone's really focused on neural techniques. But it's easy to forget the other techniques, the more traditional techniques, that are actually very good as well, and they are very easy to train. Do not use so many computational capacities. So that's I always like the ideas of keeping it simple, and then having a model that actually works.
Yeah, actually works is important. I think it's because of like the appeal of using unstructured data is so appealing with deep neural networks, that you forget that like once you have a tabular structure, once you have a symbolic schema, now say like XGBoost is the new state of the art, and deep learning is going to be like harder to adapt. And maybe you have things like missing values, all these other things that come with like these more traditional kind of data science tools, and that thinking on that kind of aspect of it. So I think we've covered a ton of interesting topics, from image search, text search, and the frontier of applying deep learning for search into e-commerce platforms. Is there anything else sort of that we might have missed with the particular application domain of e-commerce with deep learning for search?
Well, what's interesting in e-commerce is that so many of the models, the language models right now, they're trained on large stretches of text, but often in e-commerce you don't have that. Especially if you look at the queries, they're generally like 2-3 words, and that's it. That's also interesting to look at. If I know there are some models that are more trained on shorter stretches of text. But that is also a challenge for e-commerce. There isn't really a standard language model that is especially trained for e-commerce yet. So that will be interesting in the future if someone would be able to train that. I think that would help a lot of people.
Yeah, I love that. Thinking about that, like style shift. It's like kind of an abstract concept. I mean, it's very concrete when you describe style as short sequences of text compared to long sequences of text. But as we've been doing the Weaviate podcast, say you're training a chatbot model and you're going from Reddit conversations into real podcast conversations, and kind of that style shift from the underlying domain is such an interesting thing. And I guess like
Mhm.
with my kind of like academic side of this, I think these data augmentation techniques could be really interesting, as I've kind of presented this idea of maybe learning a style transfer model. So like a text style transfer model that could augment your data set by using this kind of generative model. I
Mhm.
know a lot of people who really build these systems for real are kind of skeptical about that idea of adding another model into the pipeline of generating training data. What do you think about synthetic data and data augmentation as a technique to improve these models?
Um, think it's an interesting idea, and I think in many cases it can work really well. But I always think it's a bit tricky um, if your data isn't uh, great, or if isn't that clean, and it's very difficult to well, if you keep training with the data, then it will only become more noisier. So that, yeah, I think that's definitely something that you have to look out for. But in general, yeah, using some data augmentation techniques can be really really helpful, of course. Yeah.
Yeah, I think especially if you're trying to use, say, generative adversarial network scans for data augmentation, then you have this problem of mode collapse. And then if you sample from that, you're just adding that mode collapse bias
Hmm.
and clustering your data even more on that one point. So and then just generally that idea of like compounding errors of your generative model makes an error and now you put it into your discriminative model and it just runs away with the error.
Yeah, exactly.
I like techniques like maybe variational autoencoders or these diffusion models that maybe have these explicit objectives around encouraging diversity in the generative model. I think with these language models, the way that you do the tree structured decoding, like
Mhm.
how with like OpenAI's Codex, they generate like 1,000 different potential generations, and they call this repeated sampling, where they traverse the generation tree several times and then put that into the compiler to see what doesn't like have an error because this is a model that generates code. So these kind of maybe tree structured decoding strategies could be a way to achieve that diversity in the
Mhm.
generative model.
Yeah, that's very interesting.
Yeah,
Yeah.
and I love that like idea of the generative model, but I think also just like the way that retrieve then read adds that interpretability is also such an important part of building these systems. And so are you like inspired by say these recent advances like DeepMind's retro model, maybe Facebook's internet augmented generation, or OpenAI's WebGPT, where we're seeing maybe less hype around this idea that like let's just build trillion parameter language models, and maybe more of a recent idea into let's decompose the task into information retrieval and then supervised learning?
Yeah, I think in general, maybe I'm not such a believer in like one great AI that solves everything. I think dividing it into subtasks, it will be much more effective than one that one size fits all.
Yeah, it kind of comes back into this like end to end, like people like this end to end idea where, instead of featureization and learning, we just put it into one pipeline, and maybe everything could be end to end, but maybe sometimes we need to have a task decomposition. And say like multitask learning doesn't really always work that well. Maybe if you have
Mhm.
things like, as you mentioned, the T5 framework that unifies these tasks into at least you kind of have like a similar gradient scale when you're trying to do multitask learning. Yeah, that idea of like decomposing the end-to-end pipeline into subtasks. What do you think about that kind of idea of just like, let's make this whole thing end-to-end, make everything continuous, anything discrete, let's put a continuous relaxation on it and just try to do gradients through this whole thing?
Uh, I'm not sure. I don't, it would be cool if it worked, but I have my doubts actually.
Do you have similar doubts in that kind of scope of one model that performs all the tasks to the idea of off the shelf pre-trained embeddings, like one model that say covers all the distributions of data? Do you think those two kind of ideas are the same? The idea of end to end, I can learn every task. This GPT N is the language model that does
Mhm.
everything. And then this idea that say like clip N is the embedding model for everything.
um, well, what I've learned from my experience with Clip is that it is very useful, as I said, where we don't have the data, but um, if you have any labeled data and you can fine tune it for your specific task, it's always better in
Mhm.
my experience. Um, but it's very useful to have the general model, general embeddings as a baseline. Um, but if you can fine tune it to any specific task, then yeah, that would always have my my preference. Also, for example, the GPT-3 model, I think GPT-3 is amazing and all the capabilities. It's really great, but with the prompt engineering, it's very difficult if to to steer it in your exact direction.
Mm.
It can do so much, but what we've seen a lot of times is that it will generate great text that are like you can't tell if they're human written or AI written, but it will also just make up stuff. And since it's so well written, you don't know that it's actually made up. But a lot of times information is not true, and then is the problem. Like, how are you going to check if it's not true or if it is? And so it's difficult with such models to steer it into a direction that you actually want. So if you can fine tune anything, of course you can now fine tune GPT-3 as well, and I think that that's also a great move forward to still leverage the capabilities of the model, but then actually steer it into your direction.
Yeah, that topic of fine tuning language models is, or steering. Yeah, I like that steering word too. It's really a really nice way of like trying to think of like, move this big
Yeah.
powerful ship towards some useful direction. And yeah, I like maybe like two techniques. Like as we mentioned, this idea of like generating a massive tree of potential decodings and then putting a discriminative model that parses that tree. Or maybe we've seen recent advances from OpenAI on using reinforcement learning to train a reward model and then use that to kind of fine tune the model. Or maybe you could just have supervised learning where you have some sequence to sequence data set and you fine tune it on that. But I wanted to come a little bit back to this idea of fine tuning versus off the shelf models, particularly with these embeddings. And I wonder, like, if you think that maybe there is a fine tuning bias, where, as we say that, like, having labels, it generally improves it. But is that maybe because like the train test split is from the same distribution of labels, and that might kind of bias your thinking into saying that, well, clearly I have this train test split and it's better on my test set when it's been fine-tuned on this train set, compared to maybe sacrificing the robustness and the zero shot flexibility that is kind of like maybe like the key advertisement of these models. Like as you fine tune it and you evaluate it and you say these labels have made it better, is that because you're evaluating it on the same distribution of labels and you're not really doing, say, like data augmentation corruption tests or whatever, like a domain shift test you could like, I don't think there even are great tools for that. Do you think like you're not, like, maybe people aren't properly evaluating how robust their models are when they say that the fine-tuned model is better than the off-the-shelf model?
Um, well, I think I agree with what you're saying. That of course, if you're fine tuning, then you're losing some of the zero to few shot capabilities. Um, yeah, of course, that's true. Um, I've never actually like fine tuned on a general data set that wasn't specific to a task. So I don't know if that would help, like
Yeah.
in still like maintaining the zero shot capabilities. Um, but I think if you're fine tuning for a specific task, then that's if you lose that the other capabilities, then um, of course you should be aware of that. But I don't think that should be problematic. Um, but yeah, you should definitely be aware then that if you're fine tuning for one task, it won't scale to a different task. Yeah, that's something you will lose. Yeah.
Do you think maybe the off the shelf weights and then the fine tune model could be combined in that abstraction layer where we talked about putting a random forest layer on top of different outputs of retrieval? Or do you think like having some kind of random forest on top of the two from the off the shelf and the fine tune? Do you think that would be useful, or is that just reaching for something?
So then you would put the embeddings in a random forest and
I
maybe.
think I think even just the output of the distance to the query, maybe like as we talked about,
Mhm.
just having like 5 distances returned from TF-ID FBM25 and the SBERTs, like the 2 distances of the pre-trained and then the fine-tuned. Is it earlier I mentioned the weight space ensembling technique? I think this paper was from the Allen Institute and the University of Washington, maybe others. I don't exactly remember, but it's like this idea that you do an ensembling of the weights as you go along that path from the clip pre-trained checkpoint that OpenAI releases down into this fine-tuned thing. And you could have some way of combining the outputs from each of those 2 checkpoints, and maybe generalizing that with our idea of the random forest abstraction on top of these retrieval
Mhm.
models.
Yeah, it's a very interesting idea. I'm not really sure how that would work actually, but yeah, I think it would. Yeah, it would be interesting. I'm not really visualizing it right now.
Yeah, I think those diagrams and maybe the retrieval pipelines, it's like maybe they need to be interactive diagrams where you can like
Yeah,
press plus and add more retrievals and stuff like that.
yeah.
So as we've covered so many topics, I have maybe like a meta question for you, is just asking like, what are your favorite sources of information, your favorite strategies to improve your skills as a data scientist?
Um, well, there are a lot actually. I really love working with people. For example, now for this customer that we're building a search engine, we're working with people from all over the world and people who have a lot of experience in search, and just being able to work with those people and get the knowledge from them, doing some pair programming sessions with them, and that that helps a lot, and that's very interesting. And I think that's maybe my favorite way. But also just like reading blogs on Medium, or watching videos of the Scale AI conference, for example. I think
Mm.
that's very interesting as well. So yeah, I think I prefer it to be like in person. That's my favorite way, but
Mm.
still there's so many ways to get new knowledge, and it's unending.
Yeah, I agree. The in-person thing definitely adds, like having a conference, or definitely adds a lot to it. And it's funny also mentioning the Scale AI conference. That was such a superstar lineup of talks they had this year. It
Mm,
really was. If people are looking for maybe something to watch, that Scale AI conference, you have like Clement DeLange, Richard Sacher, like a lot of these leaders of these massive companies that we're talking about most of the
yeah.
time. So yeah, that was a super cool thing. So thank you so much, Karen. I learned so much from talking to you about all these topics, and good luck with these projects on e-commerce. Such an interesting application. The Squadron Machine Learning Company. It all sounds so exciting and cool.
Yeah, thank you very much, Connor.